Huffman coding. Today we are going to learn. So what is Huffman coding? We can say simply it is a method of data compression that is independent of data type. What is data type? It is independent of data type. That is, it can be data can be an image, audio, or spreadsheet. And we can say simply, this is the definition we can say, or we can say it is a non-uniform coding, or we can say more frequency, less bit, and less frequency, more bit. Means if we are representing something, so if it occur more time, then we will represent it with less bits, and if its frequency is less, then we can represent it by more bit. So in that way we can do the data compression. So how we do data compression, we will let you know. And the application of Huffman coding, we can say simply it is used in, as we are saying, it is a method of data compression, so definitely it is used in data compression. And because we are doing data encoding, as I'm saying, if it is occur more frequently, then we represent with less bits, and if it is occur less frequently, then we will represent it with more bits. So we can say data encoding can be possible through Huffman coding. And what next? Binary tree application. It is also an binary tree application. How it works, we will see. And so now we understand basically what is Huffman coding is. So we can say simply, suppose if we are representing one bit y, suppose we are representing a with 8 number of bits. Suppose a is represented by 8 number of bits. So in that way, if we see, suppose in the similar way, A, B, C, D, E all are present here, and the number of frequency, we can say, suppose A is having 45, B is having 5, C is having 15, D is having 30, E is having 2, or suppose F is also there and F is having 3. In that way, and everyone is represented by 8 number of bits. So how many it can be if we multiply everyone with via 8? So 45 into 8, 5 into 8, 15 into 8, then 30 into 8, C, D 2 into 8, and F 3 into 8. If we multiply with them with 8 number of bits, so if we calculate it, it will be 800 bits. So we have to transfer 800 bits if we want to use the data, or if we want to send data from one place to another place. But at instead of this, if we are doing compression, as I am saying, Huffman coding is basically used for data compression. So instead of 8 number of bits, suppose if we represent all these things with 3 number of bits, 3 number of bits, like as I'm saying A. So initially, suppose A is like this one, 1 2 3 4 5 6 7 8. So instead of this, if we are representing with 3 number of bits, 0 0 1, This is 3 number of bits, this is 8 number of bits. So if we are representing the each one with 3 number of bits, then how it will happen? Let's see, let's do the calculation. Then the frequency of A is 45. Instead of 8, what we are writing here? 3. And frequency of B is 5. Instead of 8, what we are writing here? 3. Frequency of C is 15. What we are writing here? 3 instead of 8. Frequency of D is 30, and instead of 8, what we are writing here? 3. Frequency of E is 2, and what we are writing here? 3. F frequency is 3, and what we are writing here? 3. So if we do the calculation here, so what we will get? We will get only 300 bits. 300 bits. So in that way, we can say we can do the compression. Instead of 800 bits, what we need to transfer? We need to transfer only 300 bits. So this is the way by which we just do the compression. So this is all about the data compression. What is this? This is all about the Huffman coding, in which how we do the data compression. So let's we will see in the next lecture how we can do it exactly.